So here now we have two particles given by two position functions where time is greater than 0. On the time interval from 0 to 4, when is the particle 1 farthest from the origin? So for this, we think about an optimization problem. We want to optimize the position. So before I can optimize the position, I have to find its derivative. So S1 prime of t is really V1, not prime, but it's really the velocity of our first particle, and that is 4t cubed minus 12t. Nope, not minus 12t, minus 24t. So now that I've taken that derivative, I'm going to find its critical values by setting it equal to 0, factoring out of 4t, that leaves t squared minus 6. So t equals 0 or plus or minus square root 6 as critical values. So I need to check 6, or square root of 6, to see if that even is a min or max. So we're going from greater than or equal to 0 to 4, and square root 6 is in that interval. We are comparing s prime and s. So a number greater than square root 6 can, square root 6 is, let's remember, square root 6 is between square root 4 and square root 9. So square root 6 is between 3 and 2. So let's just keep that in mind. So if I want a number less than square root 6, I can pick 2. If I plug in 2 into this derivative, I get a negative. So that means it's moving in the negative direction. And then if I plug in a number greater than square root 6, I could plug in 3. If I plug in 3, I get a positive. So it's moving in the positive direction. So we know there's a relative minimum at t equals square root 6. But it's a closed interval. I need to check to make sure at my endpoints it's not necessarily a further distance. So let's first try s of 0. Well, if I plug in 0 into this function, that's 0, we're plugging it into s1. Let's do s1 of square root 6, my critical value. Well, that would be negative 36. Double check my work if you think I'm wrong. And then s1 of 4, plugging into that function, I get 64. So if I look, actually, here is my maximum distance from the origin. So particle 1 is farthest from the origin at t equals 4 seconds. In the positive direction, 64 units. And actually, we don't know that t is in seconds in this problem, we just know t. So the particle 1 is farthest from the origin at t equals 4 in the positive direction, 64 units. So notice here it's in the negative direction, 36 units, but it's not as far as 64. So don't forget to check all endpoints from optimizing a closed interval.